Good morning, ladies and gentlemen. First, I must apologize for what happened in the lecture last night. Apparently, the internet went down. I subscribed to Digicel, and soon after I broke up the class, I called Digicel and was told that they're having internet issues in my area. So, unfortunately, I was one of the customers that got caught into that issue. So anyway, what could I do? So what I have done instead is created this video so that I can walk you through what it was we should have done in the lecture last night. So, let's start. So we started Cartright Ltd. as the practice question for Unit 1, Activity-Based Costing. We started the question, and in our discussion last night, I noted that there are 3 standard inputs in the manufacturing process for goods. One is raw material, one is labor, and one is overhead costs. Now, the question focuses on 2 different costing methods. 2 different costing methods that will ultimately affect the selling price for the product. The first method that is asked for in part A of the question, which we did start last night, is the traditional approach. The other approach is the activity-based costing approach. Now, the traditional approach is much easier to understand, but it is not as accurate a reflection of the way in which the various products use up the resources of the organization in its production process. And so we're going to see in our calculation that we're going to end up with 2 different costs per unit. Part A, asking for a cost per unit using the traditional approach, and Part B, asking for the same cost per unit, but this time using activity-based costing. Now, as you go through the different practice questions which I'm going to give you for the topic, you'll note that all the questions have a comparison between the traditional approach and activity-based costing. That is a pattern. Now, Part A reads, calculate the cost per unit for each product using traditional methods, absorbing overheads on the basis of machine hours. Now, in the first table, it gives you the information or some of the information you will need to complete the calculation for Part A. The first input that I have on screen is raw material. And you'll notice that the column that we find the data for this in is described as material cost per unit. Per unit meaning 1 unit. So the information here, we're going to feed it directly into our calculation. There is no other calculation or computation needed for the raw material cost, which is our first input cost. Now, if you recall last night in the lecture, I talked about traceable cost, and I identified raw material and labor as traceable cost. I had used the example of fabric to show you that when you have a cost that is traceable, if given a particular input, you know exactly how much output you're to get. So in my example last night with the fabric, I said, if you need 2 yards of fabric to make a dress, and you're provided with 10 yards, it means therefore that you should be able to get 5 dresses from that as output. So in our example this evening, Cartright Ltd, we have two traceable costs: raw material, which we have already put in, and labor. Now the labor does require some calculation. You'll notice that where's it coming? You'll notice that in the question, it tells you how much time the staff worked on these products. It also told you how much money the staff members are paid. Now our focus is first on product D. I will be doing product D, then I'm going to ask you to pause the video to do product C and P on your own. I know that we did it last night, but I'm asking you to do it over to get the practice. So how do we arrive at the labor? We are told that from the data, 1 unit of D takes half an hour. The hours per unit for labor, half an hour, 0.5. We're told also, below the table in the note, direct labor cost $6 per hour. So it means that the staff members are paid $6 for every hour that they work on a product. So it means, therefore, that the labor cost per unit for D is 0.5 hours multiplied by $6 per unit. So the labor cost for unit D, 1 unit of D, is $3. Now the last input that we need is the overhead cost. And you were told that the overhead cost will be captured on the basis of machine hours, meaning if the overhead rate is $28 per machine hour, it means that if 1 unit of product sits on the machine for an hour, it will be given or assigned $28. So what we need to do is to ask ourselves, how much time does 1 unit of D spend on the machine? And when we look at the table, it says 1.5 hours. So, with $28 as the absorption rate per machine hour, we cannot leave off the per machine hour. We multiply that by 1.5, and it gives us $42 of overhead cost. So in total, our cost per unit for D, product D, is $65. Now, I also mentioned in the lecture last night, before we had to shut down, I mentioned that there are various ways to describe and by extension calculate the overhead absorption rate. Now in this question, it was already done for you. If, however, you're given another question, you may have to calculate this overhead absorption rate by yourself. Here's the formula, and I've given it to you here. The formula to work out the overhead absorption rate is to take your total overhead cost for the year and divide it through by an activity. In this case, it's machine hours for the year. So this is just for information purposes, because the overhead absorption rate to be used in the question was already given. So what I'm going to do now is to pause the video. What I'm going to ask you to do is to pause the video and work out for yourself the cost per unit for C and for P under the traditional approach. So please pause the video now. Okay, so we're back. Sorry. So for product C, the cost per unit is $49. Excuse me. For product P, the cost per unit is $115. Now, how did we get that? For C and for P as well, the raw material cost was provided. For the labor, you had to go to the table to find out how much labor time each unit took and multiply that figure by 6, which is the labor rate. So C took 1.5 hours of labor time. Multiplying by 6 gives us $9. For product P, the table shows that product P takes 1 hour of labor time. And so a person who works on 1 unit of P would only be paid $6. Our overhead cost, which is based not on labor hours now, but on machine hours. Product C takes 1 hour of machine time, so we multiply that. If you look in the formula bar, it's $28 of overhead rate times 1 hour of machine time. When you go to product P, it's 3 hours of machine time, which we will multiply by the 28 to get 84. So now we have completed part A of the question. We can now move on to part B. Now part B reads, calculate the cost per unit for each product using ABC principles, and you're to work to 2 decimal places, because of course we're dealing with money, and money is always quoted to 2 decimal places. Now I want you to notice something before we move any further in the question. Under the activity-based costing approach, the raw material and labor cost is the same regardless of the method that you use. So I am copying the information for the raw material and labor down to the activity-based worksheet. So the first thing to note here is that regardless of the costing method used, your raw material and your labor cost is the same. So what we're going to notice then is that if there's a variation in the cost per unit on the traditional and the cost per unit on the activity-based costing, it means that the difference must be because of how we incorporate the overhead cost. Now to continue with the question tells you that the production overhead cost for the year is $654,500. And further analysis shows that this figure for the year is broken down into 4 categories. The 4 categories are setup costs, machinery-related costs, material handling, and inspection costs. So therefore you know that once you have been given the percentages, you have to use it to determine how much of the figure, the total production overhead, relates to setups, how much relates to machinery, how much relates to material handling, and how much of that $654,500 relates to inspection. So let's put in the percentages. We have 35%, 20%, 15%, and 30%. So I have already set in the formula to receive the data. So there's an automatic calculation. So it means therefore that The $654,500 of production overheads has now been broken down into cost pools. Look at the phrase, cost pools. So these 4 cost pools are so described because all the costs that fall, for example, under setup costs, there may be 6, 7 different costs that make up setup costs. They are all connected because they have what is called the same cost driver. So here are 2 terms that I have introduced. Cost pools, which is actual dollar value overhead costs, but they're grouped in a particular way because they share something in common. They are affected by the same cost drivers. Cost drivers are actions. So the setup costs are affected by setups. The machine-related costs are affected by machine hours. Material handling, affected by the movements of stock, and inspection, affected by inspection costs, affected by the amount of inspections carried out. Now, usually I like to explain what setups are, what movements are, and inspections, because none of you, I think, in here has ever worked in a factory, and so the term may be unfamiliar. So let me take a few minutes to explain what they mean. Setups. Let's start with setups. If I were to carry the class on a tour to the True Juice factory one morning at 8 o'clock, you would see one set of team members leaving to go home. They were probably at work manufacturing, for example, soursop juice. So all through the night, the machines were running and soursop juice was being pumped into plastic bottles and cartons to be packaged and shipped out to the various supermarkets. What does soursop juice look like? It's white and it's thick. Now the team that is coming in the morning now to work the machines, they were probably scheduled for apple juice. Now apple juice looks completely different from soursop juice. Apple juice is light brown and it's thin, not as thick as soursop. Now the same machines are going to be used to manufacture the apple juice, to package it. So the dirty equipment that the night crew used and messed up will have to be pulled down, cleaned, and reassembled to facilitate the next crew that's coming in to do apple juice. What is a setup cost? Any cost involved in the action of pulling down the machines, cleaning the machines, and reassembling is called a setup cost. So the parts, the staff members, any other type of inputs, those represent the setup cost. So every time True Juice is doing a new batch of juice, changing it out from soursop, for example, to apple, they have to change out, clean up the machines in preparation for the batch run for apple juice. Now, what are movements? If you've ever been to Price Mart or to Mega Mart, you will see they have machinery, equipment that they use to move goods around. I've seen mobile steps that they move around, which allow the staff members to climb to the uppermost shelves. They also have forklifts. Forklifts are these machines that have the forks pushed into wooden pallets, and on the pallets they have these big packages, wrapped up, and they store these packages sometimes on the topmost shelves in the supermarkets. It takes money to move the stock around. You have to pay the people who drive the machines or who climb the stairs with the goods to stock the shelves. The more the goods move around, the more is the material handling cost. The more you move the goods around in the store, the more it costs you for material handling. The last one is inspections. If you go to the True Juice factory, there is a laboratory nearby. In the laboratory, you will have quality control inspectors who will come out periodically during the manufacturing process and take samples of the juice, samples of the packaging, to test it for germs, for viruses, for bacteria, for microbes. God forbid True Juice should send out contaminated juice to the public. You can well imagine that they may be bombarded with lawsuits, which are expensive. So the inspectors, the QC inspectors, the quality control inspectors, who go out and inspect the samples, inspect the products as they are being made, their costs come up into inspection costs. The more inspections you have, the higher the inspection costs. So enough with that explanation. I hope it is clear. Now these cost pools represent values for the whole year. Therefore, you need to associate them with the cost drivers for the whole year. Now, on the third table at the bottom of the question paper, it shows you 3 of those cost drivers. And it also shows you how much of those cost drivers were actioned during the year. We had 670 setups. We had 120 movements. We had 1,000 inspections. Notice that this data relates to every product, both including D, C, and P. Now, notice that the machine hours are not given in the table, but you would have had to realize that machine-related costs must be generated based on the length of time you run the machines for. The more machine hours you have, the higher your machine-related costs. Let us find out what was the total machine hours that was used up in making the 750 units of D, the 1,250 units of C, and the 7,000 units of P. Now the first table on the top of the page told you how many machine hours each unit would take. 1.5 hours for D, 1 hour for C, and 3 hours for P. The amount of units that were made or planned to be made, 750 units of D, 1,250 units of C, and 7,000 units of P. So the total machine hours that C used up during the year, the period, was 1,125 machine hours. So copying down, we have 23,375 machine hours for the period. Let me copy that in. So what does all this tell me? Now, when we were dealing with part A, we only had one overhead rate. But now that we are using activity-based costing in part B, we are ending up with 4 activity rates. 1 for setup, 1 for machine hour, 1 for material movement, and 1 for inspection. These rates relate to all the products because when we were working out the cost drivers, we used the combined cost drivers for the products. Let's look at what I'm talking about. 670 setups were used to arrive at an activity rate of $341.50 When you look at the sheet, of the 670 setups, 75 were from product D, 115 for product C, and 480 for product P. In all, 670 setups. So right across the board, these activity rates, these 4 activity rates that we get, all relate to products D, C, and P. And these rates are going to help us eventually to arrive at a cost per unit. So let's go. Now we're going to look at product D. Product D, 750 of those units are being made. So what were the resources used up by D in this manufacturing process? D used 75 setups. D had 12 movements. And D had 150 inspections. If that is the case, and the activity rate for the setup is $341.90, here it is up here, $341.90. So for every setup that D used, it cost Cartright $341.90. But when we multiply that out for the whole year, the setup cost directly relating to product D was $25,300.82. But we're not interested in a figure for the 750 units. We are interested in a figure for 1 unit. So if we take this 25,300.82 and look at the formula bar and divide it by 750, it changes this total cost into a cost per unit. Let me repeat. This 25,300 relates to all 750 units of D. We're not interested in that. We're interested in the cost for 1. So we must divide that 25,000 by $750 to get a cost per unit. Likewise, the same for the movements. D uses 12 movements for the year. Each movement of good costs the company $818.13. So if you have 12 such movements, we're looking at $9,800 and something for the year for the full 750 units of D. But we're interested only in 1 unit of D. So we divide this 9,800 figure by 750. And so the cost per unit for the movements related cost is $13.09. And the same for the inspection. So let me move the figure up to the top of the calculations there for the cost per unit. Let me move it up now. So we have 341. Let's check. 341.90. And we were looking at, oh, it was 75 setups. My apologies. I wonder why the figure looks so off. And we had 12 movements. And we have 150 inspections. Just checking back my figures. 750. And that. Okay. So let's get the figures up now. So I'm moving back up to the top here and putting in my setup cost, which is $34.19. My material handling, which is $13.90, and my inspection cost, which is $39.27. So the only one we have left, or the only one we have remaining, is the machine-related cost. Let's go and deal with that. Now, in the question, we had 1,125 machine hours that D used. So in all the resources that D used involved setup times, movements, inspections, and machine hours. Now I want you to notice something. The way I did the calculation for these three cost pools are different than what I'm going to do now. Why? Because you notice that I have a color here in peach. These three cost drivers are known as non-volume related cost drivers. They are not generated based on units produced or those activities that are directly linked to units produced. So you're going to note that you have to identify which drivers are non-volume related, because their calculation follows what we just did a while ago, where we found the total activity multiplied by the rate to get an overall cost for all of the units, all 750 units, then dividing through by 750 to get a final figure. The machine-related cost, however, these are volume-related cost drivers, meaning that they change proportionately to the amount of units made. Now, we worked out that it was $5.60 for every machine hour used. But we know that each unit of D uses 1.5 machine hours. Therefore, the machine-related cost for 1 unit of D is simply taking the 560 and multiplying it by 1.5 hours, and you end up with $8.40. So let's put that in. So what it means is we end up with a product that is costing $117.95. But wait, when we looked at the traditional, the cost for the product was $65. $65. And I said to you that the difference between the two has to be attributable to the overhead cost. Why? Because the material and the labor are the same under both methods. So it means, therefore, that if they were pricing product D based on traditional cost, they would be underpricing, meaning charging less than they should for product D. Product D's true cost is $117.95. Now then, I have completed the costing under ABC for product D. I want you now to complete the costing for product C. I'm going to leave the example for the illustration for product D on screen. You have the question paper with you. So please pause the video and take a few minutes to work out the cost per unit for product C. So don't run off and do C and P. Work out C first, then we're going to discuss it, and then you work out P later on. Okay? So please pause the video now please pause the video now and work out product C. Okay? Remember now, the Cartright company is making 1,250 units of product C for cat. Please pause the video now and do your working. Okay, we're back. And here we have the data for product C. Sorry. So it means therefore that C, making 1,250 units, used up 115 setups, 21 movements, 87 inspections, and they also used 1,250 machine hours. When we did our calculation, the cost per unit came out to be $31.46 for setup cost, $13.74 for material handling related cost, $13.67 for inspection costs, and $5.60 for machinery related costs. So let's put those figures in. The setup cost for C was $31.46. The machinery related cost for C was $5.60. Material handling for C was $13.74. And finally, inspection was $28.27. And again, there is a difference between the two costing methods. Traditional costing gives C a much lower cost, half of the cost. Can you imagine? A half of the cost for absorption. Because absorption approach is charging $100 as cost for product C. Okay, let's go down now to product P. Again, I'm going to ask you to pause the video. So please pause the video and work on product P. Okay, we're back again. And here we have the data for product P. $23.44 for setup costs, $10.17 for material movements, and $18.79 for inspection. And let us not forget the $16.80 for machine-related costs. So again, let's put our data in and look at how the costs compare under both methods. So setup is 23.44. Machinery related is 16.8. Material handling is 10.17. And finally, inspection is 18.79. Now, it's the other way around for P. Traditional costing gives a higher cost value to product P than ABC. Alright? So it means, therefore, that if product P was being priced at based on a cost of $115, it means that product P would be overpriced because its cost should really be $100. So that concludes the calculation for part B. Now part C is the discussion part of the question. And as I mentioned last night, students tend to shy away from the theory part of the question. And so what I want to do to get you into the habit of doing is facing these questions head on. So I do that through forums. So I want you to go back onto Moodle. In the Unit 1 section, look under forum and you see question C being asked. Now you have an opportunity to earn 2 points from answering part C. But here's a catch. When you're doing theory questions, it is always best to pull data from the questions before to support the comments that you're making. So the calculations in parts A and B of this question, I must see them popping up somewhere in part C, or you're going to get an automatic 0. So these forums, for every unit that we're doing, you're going to get a forum question, and you must participate by answering the question. Now the answer to part B, I have been talking about it throughout the video. In addition, if you go back to the text, you will have an idea. If you give me back the same wording that is in the text, again, it's a 0. It's called plagiarism. So these things you need to watch out for. I need content that pulls from the questions before, plus I want your responses in your own words. Okay? Now my last point before I complete the video, it's now 42 minutes of recorded video. I'm sure with you working out, it probably took an hour. I'm going to give you another practice question. I'll upload it in a little while. And you're going to try that question on your own. And I will release the solution when we meet up next week, Thursday. So I want to give you time to work through the Cartright question, go back and do your reading, and then it will be good for you to try the practice question. Now, I had hoped to have put you in breakout rooms for the session this evening. Unfortunately, Digicel did not allow me to do that. But as of next week, whenever we're doing questions like this, I would put you in breakout rooms because you need to get to know each other. Probably prior COVID, you may have met each other, but to reacquaint yourself with each other, I'll be using breakout rooms as of next week. So, ladies and gentlemen, thank you very much for paying attention and for working out the various parts as I asked. I hope you were honest and did attempt to work the different sections on your own before looking at the answer. Okay, so remember to check for the other practice question, and I will see you next week, Thursday, at 6 p.m. sharp. Oh, one last thing. There is a quiz. And I had mentioned in the class yesterday, do not attempt the quiz until you have attempted the practice questions, this one and the one I'm going to post, plus read the chapter, because you want to get the maximum marks from these quizzes. Okay? Well, you have a good weekend, and I'll see you next week, Thursday. Take care.